Assalamualaikum, and today our group will present our project about three-phase uncontrolled rectifier. The definition of rectifier and rectification. Rectifier is electrical device and its function about to converter of AC energy direct to DC. Rectification meaning the process to convert AC current to DC current. There are two types of rectifier: uncontrolled rectifier and controlled rectifier. Uncontrolled rectifier cannot control the output voltage. Next, output voltage fixed and depend to AC input. Lastly, configuration of the circuit use diode as switching component that rectify the AC input. For the control rectifier, it can control the output voltage. Output voltage can be varied and changed using the input. Use current controlled solid state device commonly such as SRCS, transistor, MOSFET and IGBTs. Type of control and uncontrolled rectifier. There are two types: half wave and full wave rectifier. For the half wave uncontrolled, use only single diode, and controlled use with single transistor instead of diode. For the full wave rectifier uncontrolled, use two or more diodes in the configuration. For the control, use two or more transistors in the circuit building. Comparison between single-phase and three-phase rectifier. It is pretty straightforward by its name, whereas the single-phase rectifier rectify single-phase AC input source, meanwhile the three-phase rectifier rectify the three-phase AC input source. For the full bridge rectifier type, the single-phase rectifier uses 4 diodes while the three-phase rectifier uses 6 diodes that have been set in certain conditions to get the desired rectification wave. That's all for me, and I will pass to my group to present the next slide.
Circuit operation, half-wave three-phase rectifier configuration and output results. In this rectifier, 3 diodes are being used to rectify the 3 AC source. The anode for all of the diodes are being connected to their each supply, while the cathode terminal being connected to the neutral to form the star connection. From the research that have been made, only one diode that can conduct the voltage at a time. The diode with the largest instantaneous voltage value that will only works in forward bias, while the other diode will be under reverse bias condition. Full wave three-phase rectifier configuration and output result. To start the explanation, must be to know that the condition to make the diode to be forward bias either one. The voltage from the anode diode must be the largest. The voltage at the cathode diode must be the smallest. For phase V3 is the maximum voltage initial on the graph. From the example of the graph below, for half cycle positive phase at the initial condition time, phase 0 until reach 30 degree, the V3 is the largest. V3 is flow to D3. Upload D5 and flow back to V2 phase voltage to D5. For phase V1 is the maximum voltage at the phase time of 30 degree, the V2 is still being as the smallest voltage value than V1 and V3. For phase V1 is, for V2 is the maximum voltage. The next 16 degree after that, V2 is the largest, that makes the D2 is being forward bias. Basically, this happen only for half cycle of each V1, V2, and V3. For the other half cycle, the same process will repeat again.
Assalamualaikum warahmatullahi wabarakatuh. I will explain about formula and calculation that have been used based on the topic three-phase full wave rectifier. Firstly, we can use this formula. We can use this formula 1 over t integrate from 0 to t vdt or known as period. This formula is used to find V average value. For the information, V average is equal to VDC. So if you then calculate V average, we can also obtain VDC value. Other than that, V average also equal to 1 over pi divided by 3, integrate from 0 to pi over 3, and this all formula V average.
Now we're gonna look for the three-phase rectifier circuit if we add RL load at the output. So we're gonna see the difference of the input current at the output. And for the RL output waveform, the principle of diodes is same as R load connection, but the difference from R load is the fluctuation of output current for RL load that makes the ripple waveform begin to be small, and it is because inductor don't allow the current through it to change in sudden condition. And then the other we also can look for other and if we add other component like capacitor. If the capacitor being put parallel to the output of rectifier, which is load, the output waveform will become more smooth due to the capacitor ability to discharge and charge, and in addition, the advantage of three-phase special form of circuit, it will make the ripple of output become small. Now, we're gonna take a look at simulation and improvement. So after the all of the simulation that we have made, we can get the for big standard mode, the output waveform is 42.9144 volt, and for RMS standard mode, we get the value is 60.7323 volt, and for peak to peak standard mode, we got 21.4073 volt, and unfortunately it is not same like calculation value because maybe there are errors happen in the calculation or the simulation. So the conclusion that can be made from all of the report that we have made, is as the summarize of the report, the three-phase rectifier could be classified
by type uncontrolled and controlled rectifier. Each of the type could be categorized as full wave and half wave rectifier. But in real life application, only full wave three-phase rectifier that being used in real world. For theoretical concept, in half-wave three-phase rectifier, 3 diode will be used that connected from the supply voltage to load. Meanwhile, for full-wave three-phase rectifier, 6 diode will be required to be connected from supply to load to produce full-wave output. The type of load between R and RL load also will be manipulated, the ripple output waveform result. With addition of the capacitor as filter or inductor as addition load, it have been known that it will reduce the ripple output waveform. So we also hashtag a few component of datasheet like resistor that can be used in the rectifier circuit. For example, this resistor that resistor datasheet that have been that was got from DE connectivity production. So this type of capacitor is type CVT series, and this is about the rating and the datasheet that have been given and provided by this production of company. And also we have datasheet about diodes rectifier that can be used in the rectifier circuit. And this is a few information about the rating of the diode. And this datasheet is being provided by Diodes Incorporated production. And also we have a few reference like journal by Octopart about power diode datasheet, and we also get the we got the different from the journal from journal TE connectivity, and we get this journal for get the datasheet. And also to get a certain amount of information about three-phase rectifier, we also refer from intermediate accelerator physics or in the chapter rectifier that which the author is Roberto Vicentini, and this is the part of journal which is tell a certain amount information about three-phase uncontrolled and controlled bridge of rectifier. So that's all about the information for three-phase uncontrolled rectifier. Thank you.